like you said, so these are some of those, some of these reviews and stuff. So we'll just kind of do, a few problems for each of these, and then if there's specific ones that you want to look at, right, make sure that you let me know, and you can definitely do that. Okay. All right, so let's look at this first one together, right? So being able to solve equations is definitely going to be something that you want to be very familiar with, one of the most important things that you probably learn in 980. So, so on this first one, right, we want to make sure if there's anything to distribute, that we want to make sure that we go ahead and get that distributed through. So I'm going to take this -2 and distribute it. Make sure whatever sign is in front of it, right, that negative needs to go with it. So when I write this down again, right, on the right-hand side, I'll have 7x minus 4x and then plus 16. Right? For some reason, that second one, when you're distributing that negative through, sometimes people forget to do that. All right, and now we've got to combine our like terms together, right? So on this side, 6 minus 2 is 4, and then you still have that plus 3x. On this side, 7x minus 4x is 3x plus 16, right? And then when we're solving this one actually comes out to be kind of different, right? Where when we try and solve for x, there's no x's left, right? And so we end up with this, 4 equals 16, right? And there's no x's left. You guys remember, what does that mean if your x's eliminate? What would our answer be there? Is that going to be a no solution, right? Because if it's all eliminated, then you'd have a no solution. Okay, so just know that can happen. It doesn't happen too often, but it could come out to be that way. All right, let's look at another one, but this time let's look at one with some fractions in it, because it seems like something like this is, students get a little bit wary of just because of the fractions. I want you to think about what can we do with these fractions here, right? So if I have 1/4 y minus 3 equals 1/7 y. Right? So two different things we could do. We could get a common denominator, but since it's an equation, we can figure out what the LCD is and then kill off the denominators. And so that's what I would suggest to do on this one. So the LCD, right, you're looking at all of the denominators here, 4, 1, and 7. And so the LCD of that would be 28. So that means I want to multiply each part by 28 over 1. And let's see, when we do that, what happens here? So 4 divides into 28 7 times, right? And so then I'm left with 7 times 1 times y is 7y, right? And there's no denominator there. I got rid of it, right? Then let's keep going here. So then if on this one, there is no denominator to get rid of, but we still need to make sure that we take that 3 and times it by the 28. And oftentimes that's the part that people tend to forget to do, is they remember to multiply it by the ones that have fractions, but you've got to multiply it by every single part. So then this would be minus 84. Negative 3 times 28 is negative 84. Okay, and then the last one here, 7 will divide into 28 4 times. And so 1 times y times 4 is going to give us 4y. And then from there, that doesn't look so bad to try and solve, right? We'll get our letters on one side, get those variables on one side, and the whole numbers on the other side. So let's do this and see what happens. So I get negative 84 equals negative 3y. Okay. Then what can we do here? And divide by negative 3, right? And so when I divide by negative 3, what do I get for my answer here? Right? So negative 84 divided by negative 3 gives me 28. So my answer would be y equals 28. And remember, with any of the questions that say solve, you can always check your answer. So you could put what you got for y back into the original, right, and check it. So I would suggest you do this on the test. I mean, some students might be afraid that they're going to run out of time, so maybe you can come back and do some of these checks. But yeah, especially if you have some time left over, make sure you're doing that. So what I had there in green first, right, that original equation is what I want to put that 28 into. So I have 1 over 4 times 28, I'll write it as 28 over 1, minus 3, and then equals 1 over 7 times my y, which is 28, so 28 over 1. All right, and then I just need to simplify this a little bit bigger. So again here I can see those, and this 4 divides into 28 7 times, so 7 minus 3 is what I'm left with on the left side, and when I divide 7 into 28 I get 4. And 7 minus 3 is 4. So that does check out. That tells us, yep, yes indeed, we did it right. That is the correct answer. Okay. So I won't do checks on all of these ones that we're looking at, but I want to make sure that you remember to do that, right, to do these checks, because it definitely can be really beneficial on the final to check your answers. Okay. All right, any questions so far on these? Make sure that you speak up if you do have a question. Like, where did that number come from, Becky? All right. Okay. Well, let's look at this one. So there's definitely going to be word problems on the final exam. And so sometimes it's, you know, you might have some where you just need to translate, right? So we're just taking this from English and translating it into math. So if we're kind of looking at these different parts, right? The word difference, right, means subtract, so make sure you know sum, difference, product, quotient. Those are 4 words that we use a lot of time in math, right? So sum is add, difference is subtract, product is multiply, and then quotient is divide. Okay, so make sure you know those 4 things there, okay? So if we're looking at this, so it says the difference of 2 times a number and 6. So since it says difference here, I know I'm going to have to subtract 2 different things, all right? And then these next parts are going to tell me what I'm going to subtract. So 2 times a number and 6, all right? So that's what goes on each side of my subtract sign. So 2 times a number, I'm just going to call that number x, you call it n or whatever you want it to, right, and 6. So sometimes when people see that word and, they think that it's add, but it's not. That and refers back to whether it's saying to find the sum, difference, product, or quotient. Right, so make sure you're clear on that. And then that word is, right, this little teeny word is here, means equal, so that's where our equal sign is going to go. Right? And then we have 9 more than the number. Well, the number that we said was x, and 9 more than that would mean x plus 9. Right? So make sure you know how to translate that, and then you're going to go ahead and solve it and figure out what x is there. Right? So let's do this. So let's get our x's on one side, and let's add the 6 over to the right side. So I'm left here with x equals 15. Right, so that would be my answer. 15 would be my number there. Okay. All right, please speak up. If you have questions, somebody else is going to have those same questions, so I really want to hear from you guys. You know, sometimes it can be a little bit scary to try and speak up, but please do. Okay, be brave. I'd love to hear from you. Okay, what about this with when we have some percent ones, right? So again, we can translate this into a math equation, right? And so if again we do kind of what we did up there, well, we've got 39, 36 means equals, and then remember that 48% you need to change to a decimal, and you move that decimal back 2 places, so that's the same thing as 0.48, right? So 0.48, and then that little word of means multiply, right? Of what number? So that would be our x. Right? And so then on this one, we're looking to see, okay, well, how am I going to figure out what x is? Well, here it's connected by multiplication, so I need to divide both sides by that 0.48 to find out my answer. Right? So you can just use your calculator to do that. Make sure you have a scientific calculator you know, to bring into the test, and because you won't be able to use like your phone or anything like that, right? You do need to, you know, make sure that you have some kind of a scientific calculator. So that would give us 82. Right, let me do this. All right. Hopefully you guys are feeling good so far here, right? Hopefully Module 1 and 2, it's not that the stuff in Module 1 and 2 is hard, it's just been a while since you've done it, so sometimes it's hard to remember back on the stuff here, right?
Stephanie, it's a non-graphing calculator, right?
Yes, it needs to be a non-graphing calculator. So if your calculator graphs at all, you will not be able to use it on the test, on the final exam. Now, there will be a scientific calculator that you can use on Proctorio, but, you know, sometimes students are kind of nervous about doing that if they haven't used it before, you know, because you do need to know how to do things with logs on the calculator, so you want to make sure that you're familiar with how to enter in things with, you know, logs. And we'll do a few of those later, but, yeah. I'm going to make sure that calculator is available. I'm just going to make myself a note to double check those settings on there that it is available. Okay. All right. So how about this one? Right. This is a good one to know for daily life. Right. So at a restaurant, the bill comes up to $79. You decide to leave an 18% tip. How much will you pay after including the tip? So let's first figure out how we would, you know, find the tip. Right? So how do we figure out the amount of money for the tip? Right? Well, if we are spending $79, then we want to find 18% of 79. So remember, that is multiplication there. So 79 times 0.18. Right, so what do we get there when we do that? So $14.22. And make sure that you're looking to see if the question is asking you to round to a certain, you know, place value. That's one of the things where students tend to make just like a little mistake that makes a huge difference on your answer. So write yourself a note somewhere down and remember to really pay close attention if it's asking you to round it. Okay. All right. So that's the tip amount. But then it's asking here, how much will you pay, you know, including the tip? So then we just need to add that $14.22 to $79 to find out that total amount, right? And so that's going to give us $93.22. That's quite a restaurant bill, right? Must have taken out like whole family, extended family, my word. Okay. All right, so on this next one, right, you need to make sure that you know how to solve for different, variables in formulas that are given to you. And so on this one, it's asking you to solve for y. And you do this a lot when you're, dealing with your equations of lines. It's just usually there's a number there for a, b, and c. But you're still going to go about it the same way. So to get y by itself, I want to first move that ax over to the other side. So that means I need to subtract ax over. Right? So that will give me by equals c minus ax. And then to get y by itself, right, because that's the one I'm trying to solve for, I want to divide by b. So y is c minus ax all over b. Right? Or if you put that ax in the front, that's fine. It could be negative ax plus c all over b. Both of those answers are correct. Okay? All right, and there are going to be a few questions on the test. They're kind of like different types of questions. Some of them, they give you kind of a multiple choice of answers to select from. There's not too many multiple choice on there. There's a few. A lot of them are just, short answer or graphing, on a grid. And it's really, the graphing stuff is going to be very similar to how you did it on your homework. So as long as you're familiar with your homework graphing, you will be great on there. Okay, let's look at another story problem. All right, everybody wants to always look at story problems because they kind of give us, sometimes it gives us a little bit of grief or a little anxiety. So let's look at this one and see if we can figure out what we want to do. So Sarah's goal is to find a job that provides an income of at least, right, so there's an important part, at least $65,000 a year. The company offers a job paying a base salary of $17,000 a year plus a 4% commission of her sales. Determine the amount of Sarah's total sales, right, so that she can get a yearly income greater than or equal to $65,000. All right, so the first part of it is we know, like just because of this last part here, greater than or equal to, right? So we're going to say, okay, well, we know that she wants to end up with an income that's greater than or equal to $65,000, okay? And then this other side is kind of the trickier part, right? So we know that she has a base salary. So if she doesn't sell anything, she's going to at least make $17,000, right? Which isn't a great amount if she's trying to get the $65,000, right? So commission can make a really big difference. So added to that, whatever her base salary is, right, she's going to get 4%, right? And 4% is the same thing as 0.04, right? So I'm going to change it to a decimal there. So plus 0.04x, right, where x is going to represent her total sales. Okay. All right, and then remember when you're solving an inequality like this, you still take the same steps that you did when you are solving equations. It's just now you have this greater than or equal to sign that we're going to keep in there. All right, so to get x by itself, let's start by subtracting the 17,000 over. All right, and so that's going to give me 0.04x is greater than or equal to, what's 65,000 minus 17,000? Give us 48,000. And then the last thing I need to do to get x by itself, it's connected here by multiply, so let's divide both sides by 0.04. Right? So 48,000 divided by 0.04 is going to give us a pretty big number. When we divide by a really small number like 0.04, gives us a big number. Right, so I find that x has to be greater than or equal to 1,200,000. Right? So that's how many, how much she has to sell in product that year in order to reach her goal to make $65,000 that year. Okay, any questions on that one? Sometimes it can get a little bit tricky. All right. Hopefully you guys are doing well. Maybe, if you want to write something in the chat or something too, you can do that if you don't want to speak out loud, but I'd love to hear from you. Okay, so now the next thing that we're going to be moving on to are these compound inequality statements, right? And you've got to remember these or statements and statements. So when you have an or statement, you're looking for the union, right? And so that union means everything, right? All of the elements in that first inequality along with the elements in that second one. So it's kind of like everything that appears in both. Sorry, not appears both, but yeah, it appears in both. But the and statement, right, is just the overlap. So it's the intersection, but we want to know the overlap. Right? What parts do they have in common is what we're looking for there. Okay, so let's look at these two. So basically you'll solve these separately. Right, so I'll start with this first inequality. If I have adding 2 over, so I'll get 3x is less than -9, and then divide by 3, so x is less than -3. Okay, and then on my other one, I need to add 4 over, so that's going to give me 4x is greater than or equal to -4, and then divide by 4. So x is greater than or equal to -1. Okay, but we're not done yet, right? So we have these two answers, but now we need to graph it, right? So let's make a little number line here and graph it. So I've got -3 and -1. Remember, since this is a number line, the smaller numbers need to go to the left, and the bigger numbers go to the right. Okay, and so when I'm looking at this, I've got x is less than -3. So that means I'm going to have an open circle here at -3 and all the stuff to the left. Okay, on the other end, I have x is greater than or equal to, so since it has the equal to part, that means it has a closed-in circle, right? And then everything bigger to the right of -1. And then the last thing that you need to do here is it asks you to write this answer in interval notation. So when we're looking at this, remember that union is saying, all of this stuff, to the left there and all of this stuff to the right. Right? So it's both of these together. So when I do this, right, you're always doing your interval notation from smallest to biggest. So make sure you're putting it in that way. So it's going out to -infinity, and it's going to go to -3, but it doesn't include it. So we're going to use a parenthesis there. And then union, square bracket, -1 to +infinity. That looks like a parenthesis see there. All right, so make sure that you're really clear when you're going to use the parentheses or when you're going to use those square brackets. Remember, you always put parentheses next to infinity or negative infinity. Okay. All right, let's try the next one also. So this time it's an and statement, but we're still going to, go about kind of solving these in a similar way. So on this first one here, let's start by distributing that 4 through. So I get 8x minus 12 is less than or equal to 12. Okay, so I'm going to add my 12 over. And so I'll get 8x is less than or equal to 24. And if I divide both sides by 8, I get x is less than or equal to 3. Okay, let me move this one over here so I have a little bit more room. All right, so now, when I'm looking at this, I want to get my x's on one side, and whenever you're solving inequalities, you always want to get your x's on the left. And I say that because otherwise, if you move them to the right side, you're going to be reading that inequality backwards, and that usually messes students up and, and thinking through it. So just remember, move all of your x's to the left side, okay? So here, I'm going to add 5x over, so I get my x's over on the left. And then I'm also going to add my 7 over to the right side, okay? So then that's going to give me negative 3x is less than negative 1. And so this time I'm dividing by a negative 3. So I need to remember when I'm dividing by, multiplying or dividing by a negative, I've got to flip the inequality. All right, so remember that. And so that means that my answer is really going to be x is greater, I'm going to put this in, notice that I'm flipping it, right? X is greater than positive 1/3, because a negative divided by a negative is a positive. Okay? And then if we, graph this and figure out the interval notation, I kind of wrote other stuff here, but let's just do it down here. Put some space here for it. All right, so go ahead and put these on your number line. So 1/3 is smaller than 3, so we'll write it like this. Now 3 has the equal to part, right? So it's going to have, a different color here. So we'll have 3 and everything to the left, where x is 1/3, but not including 1/3, and everything to the right. So again, we're looking for the overlap of this. So that means it's going to be the stuff in between 1/3 and 3. Right, so when I write that answer down in interval notation, I'll have parenthesis 1/3 to 3 bracket. Right, remember your open circle and your closed circles, how they correspond with your parentheses and your brackets. Okay. All right, questions there? Are you guys still doing okay? Okay. I hope that you guys are remembering.
Okay.
Doing good?
Thank you.
Yeah. Okay, so let's look at one other one here. So if you have a statement like this, right, so these are called tripartite compound inequalities because there's 3 different parts to it. These are always and statements. So even though it doesn't say the word in there, you got to remember that this is an and statement. Okay? And so we are looking for the overlap, right? What's in common on this one. And so to do this, right, you're really going to just, you need to get x by itself in the middle. I'll write that here. So get x by itself in in the middle. Right, that's what we're trying to do here. So to get x by itself, that means I need to add 1. But I don't add 1 just to one side and the other like we do with an equation, because I have 3 different parts. So I need to add 1 to the right side over there and add 1 to the left side. Right? So that gets rid of the 1 there in the middle. So I'm left with negative 12 is less than, all that's left in the middle now is 4x, and then is less than 7 plus 1 is 8. Okay, and then x is still not by itself in the middle. We got to get x by itself. It's connected by multiply. So let's divide all 3 parts by 4. Right, now notice we're not dividing by a negative 4. Right, if this was, if we were dividing by a negative 4, that's when our signs would flip. But sometimes people get confused and look at this and go, wait a minute, does my sign need to flip? No, because the first number that we had was negative, but what we're dividing by is positive. Okay, so I'll have negative 3, my signs stay the same direction, is x, and then is less than 2. Okay, and then again, it says it wants you to graph it and get your answer in interval notation. Hey, but when you read this mathematically, right, you could say negative 3 is less than x, which is less than 2, but a better way to read this is that x is between negative 3 and 2. Right? So if you read it like that, it makes it a lot easier to graph it, because it's, you can kind of see in your head, oh yeah, it's saying it's the stuff between negative 3 and 2. So that's the easiest way to do these. And whenever you have these tripartite ones, they'll always be, something in between. They won't be going out from each other. They have to be something in between like this, right? So our answer for that in interval notation, right, is going to be parenthesis, negative 3, comma, 2, parenthesis. Right? Those are both open circles, so we need those both to be parentheses this time. All right. I sure hope you guys are seeing this. If I need to slow down a little bit, let me know too. Sometimes I get so excited when I'm teaching math, right, that I get going kind of fast. All right, so with absolute values, right, when we're solving these, remember that with absolute values, right, there's 2 ways to get the same answer. So this is just kind of a little side note over here. But if I had the absolute value of negative 3, right, and absolute value means the distance away from 0 on the number line, so negative 3 is 3 places away from 0. But if I take the absolute value of positive 3, well, positive 3 is also 3 places away from 0 on the number line. So 2 different questions are going to give us the same answer, right? And so that's why it's important to remember when we're solving absolute values, you're going to write 2 different statements so that you can account for, well, what if it was negative or what if it was positive, right? So the way I like to do it is keep, that absolute value part. So I'm just going to take it out of the absolute value. So I'll have x plus 5 equals 10. So that's going to be our first statement. And then our second one, it'll be that x plus 5. But now we need to change that to a negative 10. Right? So this is kind of helping us see what happens if it's the positive or negative. So you should end up with 2 answers on these type of questions. Okay, so kind of keep that in mind. And so here, to solve for x, I just need to subtract the 5 over. So x equals 5. Here I'm going to subtract the 5 over. And I get x equals negative 15. And so those are my 2 different answers. And again, I can check those, right, and put them in here. If I say put 5 in there. 5 plus 5 is 10. Absolute value of 10 is 10. I put negative 15 in there. Negative 15 plus 5 is negative 10. The absolute value of negative 10 is positive 10. All right, so those both check out like they should. So again, when it says solve, think about doing some checks, right? To make sure there's no reason why you should miss any of those questions that say solve, because you can check them. Or at least you can go back if you know, oh, that didn't work out, right? What can I do to switch it, you know? All right. So, okay, one more question that we're going to look at here for Module 1 and 2. So at the very end of Module 2, we learned about functions, right? And we talked about this function notation. And so when it's asking you to find f of 2, it's basically saying put 2 in place of x and figure out what our answer is. All right, so if I write this down, I'll have 3 times, so in place of my x, I'm going to put 2. So 3 times 2, and then that's squared, plus 3 times 2, and then minus 8. Right? And some of your calculators will let you put that whole thing in, right? But if not, make sure you're following the order of operations. So we have to do 2 to the second power is 4. So I'll have 3 times 4, and then let's multiply those together. Right? So I get 12 plus 6 minus 8. Right? So 18 minus 8 is going to end up giving me 10 for my answer there. All right, but like I said, on this one, you know, if your calculator will, you know, put that whole thing in, that is just fine. You can put that in there. Okay? But if not, make sure you're using that in the order of operations. All right, but this next one tends to be where there's kind of some trickiness involved, because that negative can sometimes cause some issues there. So let's second, a little bit more room here. All right, so now I'm going to put that negative 2 in instead. Right? So I'll have 3 times negative 2 all squared, plus 3 times negative 2 minus 8. So again, if you're following the order of operations, we've got to square before we multiply. Right? So negative 2 all squared, right? We're thinking negative 2 times negative 2 gives me positive 4. So I have 3 times 4, right? And then plus 3 times negative 2, so that's going to give me a negative 6, and then minus 8. Right, so I'll have 12 minus 6 minus 8. So 12 minus 6 is 6, minus 8 is going to give me negative 2. Okay, so just be really careful when you're dealing with those negative numbers, right? Watching those signs closely.
Hey, Becky.
Yeah.
I have a question on the absolute value one. For some reason, absolute values confuse me.
Yeah.
So, for the second equation, I thought that you were supposed to reverse the sign of, like, the 5 that's, so in this case, the 5 that's inside the absolute value.
So a lot of times students make mistakes when they do that. So that's why I say just to change it over here. You can change one side or the other, but if you change this side, so let me show you over here, you'd have to change that to negative x minus 5 equals positive 10. Right? So, and then when we do it this way, we'd come up with that negative 15. So let me show you. So if we add the 5 over, right, then we have negative x equals 15, and then we'd have to divide by that negative 1, and so we come up with that negative 15. But usually what happens is students, when they do it this other way, is they'll forget that they need to change that x to a negative also, because you have to make everything inside that absolute value its opposite, right? And so either way is fine. You can change, you know, the signs inside there, making sure that it's negative x minus 5, and then keep that as the positive 10. That's the same exact thing as multiplying the 10 just by a negative 1. You see how you get the same thing there?
Okay, cool. So it's
Yeah.
just one-time equation.
Yeah, so so if you're used to doing it that other way, keep doing it that way, but just make sure you remember to change both of those signs. Otherwise, you're going to miss that. Like I said, that's why. So I know, since you guys are learning from the videos and stuff, this is the way when I have a 980 class in person that I teach it this way, not this other way. But both of them work. So just, as long as you understand they both can get you that same answer, that's great. Good question.
Okay, cool.
Yeah.
Thank you.
No, I'm so glad you asked. Because those absolute values can be really tricky. All right. Okay, so let's keep going here. So module 3, we did a lot of stuff with linear equations. So we did some graphing with it. You had to learn how to write equations of linear, equations of lines. And so let's start off with talking about graphing this. So there's a few different ways that you could graph something like this. Okay, and I can go about it a couple of different ways if you'd like to. One of the ways that they talk about is if you have something like this, to find your X and Y intercepts. So I want to talk about that and make sure everybody's clear on how to find X intercepts and Y intercepts. So to find an X intercept, you're going to let Y equal 0 and solve for X. Okay, and if you are finding a Y-intercept, you're going to let X equal 0 and solve for Y. Okay, so make sure you go into the test knowing this, right? How to find X and Y intercepts. Okay. So if I do that on this one, right, I can see, all right, so I need to put 0 in place of my Y, so that means I'll have 2x plus 3 times 0 equals 0. Well, here I get, that's just 0, so I have 2x equals 0. And if I divide by 2, right, 0 divided by anything is still 0. So I get x equals 0. So that means my x-intercept, right, is 0, 0. Right, because 0 is what I came up with for my x, and 0 is what I put in for my y. Okay? And if I do this the other way too, look at what happens here. Right? So if I put 0 in for x this time, so I have 2 times 0 plus 3y equals 0. Well, 2 times 0 is just 0. And again, if I divide by 3, 0 divided by 3 is 0. So on this one, right, when I try and use my x and y intercepts to graph this, it's going to be a little bit hard because it only gave me 1 point, right? So that's not going to help me, graph this. I know that this 0, 0 is one of the points, but I need to get another point also on my graph, okay? So one of the other ways that you can do this is you can take your equation and get y by itself. So let's do that with this. So if I have this 2x plus 3y equals 0, so let's solve for y and get y by itself. So I'll have 3y equals negative 2x, and then I need to divide by 3. Okay, so y equals negative 2/3 x. Alright, so now I can pick any value that I want to for x, and I could figure out what the y is. Right, so you could, maybe I'll just say, if I let x equal 1. Well, let's see. That's not the way I want to write it. Write it differently. Make sure this is making sense. Let's make a little chart here. Alright, so if I choose 1, and maybe I choose negative 1 also, so I can see what happens here. So if I choose, well, actually 1's not going to be the best number, especially when you're graphing. I mean, I could graph it here, but when you're graphing on the computer, right, oftentimes it doesn't let you do things with like decimals and fractions and stuff. So let's look and see what would be a better option here, right? So since my denominator is 3, I want to pick multiples of 3. So maybe I'm going to pick 3 and negative 3 instead. Okay, and if I put that in there, so negative 2/3 times 3 over 1, right, and my 3's divide out, and I'm just left with negative 2. So I found the point 3 comma negative 2. So that's another point on my line. Right, and if I put negative 3 in, so I've got negative 2/3 times negative 3 over 1. Okay, and this time a negative times a negative is going to give me a positive. And again, those 3's divide out, so I get negative 3 comma positive 2. Right, so if I graph these on here, then so over 3 down 2 would be here, and over negative 3 up 2 would be here. Okay, and so that would be my line. Right, the other way that you can do this is if, so let's go back to this equation. If you got to this point, all right, remember this is the slope that's in front of the x, and this number, if there was a number here, that would be our y-intercept, right? And so we know our y-intercept is right there at 0, 0, and so then you could do the slope from there. So I could go down 2 and to the right 3 to get that other point there. Right, so several different ways that you can do graphing. I would suggest just pick a way that you like best, that works best for your brain, so that you can, you know, just kind of have a way to get these done. Okay. All right, what about this one? So y equals 4. So a lot of times students look at that and go, that doesn't look like a line, so how am I supposed to graph that? Okay, but it is a line. Okay, so let's look at what it's really saying. So if I was to think of, you know, some x and y, like I do about xy chart here, it's saying that y always has to be 4. So no matter what x I put in, right, doesn't matter what I put in there, y is always going to come out. Right? And so then if I tried to graph that, so I'd have over 0 up 4 would be here, over 1 up 4 would be here, over 10, wherever that is, up 4 would be here. Right? So I end up with this horizontal line on the y-axis at 4. Right? So remember that this is always a horizontal line. What kind of slope do horizontal lines have? What slope is that? Anybody remember? It's just flat like that.
0?
Yeah, it's 0. Okay, so I'm going to write that down too, just to help you remember. It's always a good thing to keep in mind that horizontal lines always have 0 slope. Okay, but let's compare it with this x equals negative 2 graph. Right, so this time, if we made our little table of values here, right, now it's saying x is always negative 2. It doesn't matter what y is, x has to be negative 2. Right, so if I put in negative 1, 0, and 1 there, right, because those could be any numbers, and then I tried to graph it. Let's see what this looks like. Right, so negative 2, negative 1, so over negative 2, down 1, it's going to be here. Over negative 2, up 0 will be here, and over negative 2, up 1 will be there. So this time I've got a vertical line. Right? So x equals some number. Those are always vertical lines. And what kind of slope do vertical lines have? It's not 0, right? Those are horizontal, but it's going to be undefined slope. Okay, keep that in mind. So vertical lines always have undefined slope, and horizontal lines have 0 slope. Okay? And I had, students just kind of tell me when they look at, like they have a graph of the horizontal line or something, they're thinking, okay, well, it's kind of like I'm just, walking, like on a road that's not going up or down, right? So there's no slope there. However, if I tried to walk on this, right, like straight up and down, right, so that's pretty impossible to do, right, unless you're attached to it somehow. So they think of that as undefined slope. Okay, so just some silly things that I've heard from students that I like to help you remember which one's which, because it's easy to get those two mixed up in your mind. Okay. All right, so let's graph one more here, but this time this is an inequality, right? But we're going to still start it off similar to how we would just graph lines in general, right, when it's an equation. So let's look at this. So first thing I want to do is I'm going to solve and get y by itself, right? To me, that's the easiest way to go about graphing lines. So I get y is less than or equal to negative 2x plus 2. And I'm putting it in this form where my x is first because I'm trying to get it into that y equals mx plus b form. Right? Because remember, in this form, b is the y-intercept and m is your slope. Right? So that helps us, we can pick out two really important parts of the line if we write it in this form. All right, so then I'm going to make a little, here's my graph over here, but let's make a table of values. All right, and I can choose anything for my x that I want. So usually I like to pick -1, 0, and 1. So I have some, see what's happening on the negative side there too. So if I put this into my equation, -2 times -1 plus 2, right? So -2 times -1 is 2, plus 2 is going to give me 4, right? So one of my points is -1, 4. All right, and let's put 0 in. So if I have -2 times 0 plus 2, anything times 0 is 0, plus 2 gives me 2. So that's the point 0, comma 2. And now let's put 1 into our equation here. Right? So -2 times 1 plus 2. So -2 plus 2 gives me 0. So another point I have is 1, comma 0. All right, so let's graph these on here. Now remember, maybe a couple of other things that we should bring up here. If you have the less than or greater than symbols, then you're going to be using a dotted line, right? But if you have the less than or equal to or the greater than or equal to, then you'll use a solid line. Okay? So since we have the equal to part, this is going to be a solid line when I connect these together. All right, let me just draw some little markings out here a bit. All right, so left 1 up 4, over 0 up 2, and then over 1 up 0. And so I can see this is going to be my line, something like this. Okay? If it didn't have the equal to part, then I'd make that a dotted line instead. Okay, but we're not done. Now the last thing you have to do on this part is you've got to do some shading. So which side of the line is going to be shaded? Well, when you're reading this, we're saying y is less than or equal to this line that we just found. Okay, so I know that they talked about doing test points and stuff on the videos that you watched, but if you can think about it in your mind and just say, yeah, less than this line would be all of the stuff below it, right? And so that is the part that needs to be shaded. That means any of these points that are over on this side of the line are all going to be solutions, right? But if you pick any points on the other side of the line that's not shaded, those will not make this statement true. Okay? Does everybody see what I mean there by just looking at that and being able to see that it's going to be the stuff below it?
I don't really get that. This part is always confusing.
Okay.
Yeah.
So let's do a test point then, okay? So on the videos, they did a test point. So if we're choosing like this point right here, 0, 0, seems to be like an easy point to pick. So if I put this test point of 0, 0 in place of my x and y, and I can actually put it, usually we go back to the original statement, but on this one it doesn't matter specifically. But if I'm going back to that, so I have 2 times 0 plus 0, is that less than or equal to 2? Right, so I just put the 0, 0 there in place of my x and y, so I have 0 is less than or equal to 2. So is that a true statement? Is 0 less than or equal to 2? And it is, because it's less than 2, right? So that means that point is part of my solution. So that means every point on this side of the line, if we chose any of these would all work out, right? But let's look and see if I chose, a number over here. So let's do a test point right here. So I can tell that that one is not going through my line here. So that's the point 3, 0, right? So if I put that into that original equation, I'd have 2 times 3 plus 0, is that less than or equal to 2? Well, here I get 6 plus 0, so is 6 less than or equal to 2? No, this is a false statement, so that means that point is not part of the solution, so none of the points on this side of the graph, or this side of the line, will be solution, so I have to pick the other side of the line. Does that make more sense? Or is that still?
Yeah, that was helpful. Thank you.
You're welcome. I know it can get a little bit confusing there, but if you, can kind of look at it and, say, okay, if it said less than or equal to, there's my line. The stuff that's less than it is the stuff below it. If it said greater than or equal to, then I'd want the stuff above that line. So it's just another way to think about it, but if you're like, oh, I want to do the test points, then do it, right? Just to double check. Always do whatever you think is going to work best for your brain.
Also, regarding questions like that, do you know if it will say to shade, or if it'll remind you to shade? Because I feel like if it just, like on this question here, it just says graph and then has the equation, I feel like I might forget if it doesn't shade. The next step is to also shade.
Yeah, I believe on a test, so remember that usually it won't say like to shade it and stuff, but this one is actually going to be a little bit different, and they will, they're going to have a graph already drawn there, and so there'll already be shading in it. So meaning, like if you went, maybe if they gave you this graph here, it would want you to try and match it to an equation. So it's kind of going backwards from what we just did, is I think how this one is set up on the test. But, if you can look at this, right, and be able to tell, okay, well, it's going through, I can see my Y-intercept is at 2, so I know, like when I'm looking at this, I have to have a plus 2. right? And then I'm looking at that slope right there, that -2. Well, that's saying from my y-intercept, I'd go down 2 and right 1. So it's kind of like you have to, I mean, you could either try and graph out all of the different options they give you, or, you know, use some of these things to help you remember, okay, my y-intercept and my slope, it's got to match up here. And then if it's shaded below it, right, then it has to be that less than or equal to sign. Does that make sense?
Yeah, thank you very much.
Yeah, sure. Okay, let's look at this next one. We are trying to find the slope and the y-intercept of this equation. And I'm going to also ask you guys to find the x-intercept again, because I want to make sure you know how to do that. Okay? Hint, 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 to make sure you know how to find x and y-intercepts. Okay, but when we're trying to find the slope and the y-intercept of this line, right, it's best to get it into that y equals mx plus b form, because we can see the slope, we can see the y-intercept once we get it in this form. Right, so let me move this over here. So if I have -6 plus 8y equals -32, so I'm trying to solve for y, so let's add the 6x over. So I'll get 8y equals 6x minus 32, and then divide everything by 8. So y equals, well, 6/8 can reduce, right? 2 will go into both of those. So that will really be 3/4 x, and then -32 divided by 8 is -4. Okay, so when I have this, you've got to make sure that you remember to reduce your fractions on this, because when it's asking for the slope and the y-intercept, if you left your answer as 6/8, it is going to mark it wrong. So make sure you're always reducing that fraction. So slope is 3/4, the y-intercept is -4, but if I write that as an ordered pair, right, this is where we've got x equals 0, and that would be our y. Okay. And then let's look at, finding the x-intercept for this again. So I'm going to go back to this original one. Remember, with x-intercept, we're going to let y equal 0 and solve for x. Okay, so let's do that here. So if I've got different things, so if I have -6x plus 8 times 0 equals -32. Right, well, anything times 0 is 0. So here, I just need to divide by 6. So x equals, and then I want to look and see if that can reduce, right? I can definitely tell that 2 will go into both of those. So that would give me 16/3, right? If I divided both the top and bottom by a -2. And so that would be my x-intercept, and I'd write it down as 16/3 times 0. Okay, so this is where it crosses the x-axis, and this point here is where it crosses the y-axis. So those are important parts of our graph, so it's a good thing to make sure you know how to find those x and y-intercepts. All right. Let's see. Oh, I'm sorry, you're not doing well. Just a second, somebody's asking me a question. Yeah, so you can make sure you bring paper to the test, right? So blank paper, and then make sure that your calculator is not a graphing calculator, just a scientific calculator. Make sure it has a log button on it, because you will need a log button, okay? And if you feel a little bit better, you can find this recording that I'm going to post. It'll be just in the final exam module, so if you go clear down to the bottom of your modules, you'll see the video recording for this. You feel up to it later to finish watching it, okay? I hope you feel better. I'm so sorry.
Thank you so much. Okay.
Okay, bye.
Yeah. How are you?
Okay, so let's look at 23 now. So I want to talk about this rate of change. What in the world does it mean if it's asking you to find the rate of change? It's the same thing as slope, right? So whenever you see if it says find the rate of change, you're really trying to find the slope, right? So let's remind ourselves we need to know the slope formula. So that would be y2 minus y1 over x2 minus x1. Well, with the way this is written, right, it's not showing, like these as ordered pairs. So, sometimes people are like, well, how do I do this? Right, but we could write these down that they give us here in ordered pairs, right? So our x is going to be the year, and then our y is going to be the number of jobs, right? Because we're trying to figure out jobs per year. So this part is important because that means, right, our jobs are the y, and then our year would be the x's. Does that make sense? No, because we want jobs per year. So if we write our first point, so it says in 2008, there were 762 jobs. In 2012, there were 846 jobs, right? And so now we're trying to find the rate of change from 2008 to 2012. So we're basically just going to use the slope formula here, right, using these. So I'm going to do 846 minus 762 over 2012 minus 2008. So let's subtract those top numbers. So 846 minus 762 gives me 84. Right, so the difference in the number of jobs for all 4 years was 84 jobs, right? It increased 84 jobs. But over 4 years, right, 2012 minus 2008 is 4. So then I just need to divide those to find what my rate of change is per year. And so that means that there's 21, right, new jobs per year. That's what we found there. Any questions on that? All right, I want to make sure we get through, let's see, almost to Module 5 and 6, but there's a lot of stuff on Modules 5 and 6 that I want to make sure we get to. So make sure you know how to solve doing substitution and elimination. I mean, on the test, you're not going to be able to tell which way you solved it, but remember, if you have a variable already by itself, like on this one, right, we've got x by itself, so we're going to put all of this 2y plus 5 in place of x in our other equation. Right, so we'd have negative 5 times 2y plus 5 minus 6y equals 39. And so now I just have y's left, so I need to solve for y. So I have negative 10y minus 25 minus 6y equals 39. Let's get our like terms together. So negative 16y minus 25 equals 39. Right, and now I need to add the 25 over. So here, I add that. I get 64. And now I need to divide by negative 16. So y equals negative 4. Right? But I'm not done there. Sometimes students, think, oh gosh, I did all this work. I've got to be done, right? But no, we just found our y value. But you also need to know what your x value is, right? So let's take that answer that we just came up with and let's substitute it into one of our two equations. Well, it's going to be easiest to put it into that bottom one. So if I have x equals 2 times negative 4, goes in place of my y, plus 5. Let's multiply those together, so negative 8 plus 5, so x must be negative 3. So the point in which these two lines cross each other are at the point negative 3, negative 4. And that would be your solution there. Okay. And then when you're trying to solve something by elimination, these are easiest to do if you have, your x's lined up underneath each other, your y's lined up, and then your whole numbers, right? And I can see right here, if I add these together just the way they are, right, can you see that my y's will eliminate? And if they won't eliminate, you've got to multiply, each equation, by something to make them eliminate. So, make sure you look back up, some of these substitution and elimination problems, making sure you remember how to do these, okay? This is going to be really important. Those of you that are going into 1010 next, going to be using this quite a bit, okay? So when we add the rest of this together, we're left with negative x equals negative 1. If I divide by negative 1, I get x equals 1. Okay, but remember that's only part of my answer, right? My x is 1, now I need to go find my y. So again, I can take whatever I got and put it back into one of my two equations. And it doesn't matter which one, I'm just going to put it into the top one here. So I have, in place of x, I'm going to put positive 1 minus 2y equals negative 17. So subtract my 1 over. Negative 2y equals negative 18. And then I need to divide by negative 2. So y equals 9. So my point this time, right, in which those two lines intersect each other is at the point 1, 9. Okay. Alright, so I'd say, if you're feeling like going, oh, it's been a little while since I've done those, go back and look over some of these, right? So any of these that I go through today and you're like, oh, how do I do those? Again, I want more practice with them, right? Go back to your reviews, go back to your, quizzes and stuff like that. Try and find some problems like these on there, and that will make it, so you can practice some more of these. All right, what about if we have a story problem where we have to use systems of equations to solve it, right? And they're not going to tell you that you need to solve systems or use systems of equation. But you can kind of see that there's, some different things that we're talking about here. So let's read through this. So the admission fee at an amusement park is $10 for children and $15 for adults. If one evening 537 people attended, and the amount of money they collected was $6,265, how many children and how many adults were admitted? All right, so those are the two things that we're trying to find. So I'm going to say C is going to be the number of children, and I'm going to say A is the number of adults. Okay, trying to make sure that I write down what my variables are standing for, especially if you use like just X and Y and stuff. Okay. All right, so let's look at this first part here, because oftentimes this is the one that a lot of people have a hard time, figuring out the equation for this, because all it says is there's 537 people that attended. Well, do we know how many children and do we know how many adults attended? No, that's what we're trying to find here. So we're going to say, C plus A has to equal 537 people, right? I don't know how many of each. Maybe I have 500 children and 37 adults. Well, that would be a really crazy amusement park, maybe, if there was like that. But you see what I mean, right? Or you have, 400 of one and 137 of the other. There's a lot of different combinations that you could come up with to get that 537. So we need the other equation to help us figure out how many children and how many adults there were. All right, so on our next equation, right, we got, okay, so children, I don't know how many there are, but I know that they cost $10 each. So 10C plus, well, adults cost 15, so 15A, and then the total amount that was collected was $6,265. Okay, so now I have my two equations, and now I can use substitution or elimination to solve it. So I'm going to use elimination since I already have, like, my C's are lined up, my A's are lined up, and my whole numbers are on the other side. So in order to eliminate this, right, I'm going to eliminate the children here first. So that means I need to multiply this top one by negative 10, right? Because if I have negative 10C plus 10C, that will eliminate that variable of C. All right, but I'm going to distribute this through and put it underneath here. So I have negative 10C minus 10A equals, I'll distribute that through, it's negative 370. Sorry, that just looks weird. It doesn't look like there's a negative there. Okay, that should be negative there. All right, so the C variable eliminates. Add the A's together. That gives me 5A equals, and now let's subtract these. 5 to 8. Right, so it looks like that's 895. Right, and then I need to divide that by 5. I came up with 179. So A is 179. So what is it that I found? Well, this is how many adults, right? So there were 179 adults, right? And then how am I going to figure out how many children there were? Well, let's go back up to this original one here, right? Let's substitute 179 back in place of our A here, right? So if I have C plus 179 equals 537. Right, then I'm going to minus my 179 over, right, because I know together they have to be 537. So if I just take that 537 minus my 179, I get 358. Right, so there's going to be 358 children. And if we add those back together, we better end up with that 537 because we're saying adults and children together should be that 537. Right? And so those would be my solutions there. Okay, hope you guys are hanging in there. I know it's kind of long going through all of these, but I'm just trying to pick some of the ones that I think would be most important for you to kind of look at. Okay? And let's see, some of these wouldn't come over very good. So let me write down what this one is. So on the Module 5 and 6 review, number 16 is dealing with some properties of exponents, right? So if I have something like this, so 3x to the negative fourth power, y to the second, right, over x to the fifth, y to the fifth, z to the fifth, and then this whole thing is raised to the negative third power, right? And so there's a lot of different ways you can go about simplifying this, because that would be the instructions, would be to simplify. But what I like to do is get rid of any of my, get rid of my negative exponents first, because I think it just makes it easier. There's a lot of mistakes that can be made with negative numbers, and I don't want to make those. So this negative 3 on the outside is telling me to flip everything inside. And if I flip everything inside, then that will be a positive 3 exponent. So that's what I'm going to start with. So everything on the bottom, just like it is, x to the fifth, y to the fifth, z to the fifth, goes on the top now. And everything on the top is going to go on the bottom. So 3x to the negative fourth, y to the second. Notice that stayed a negative 4, because the only negative I was trying to deal with right now was that negative on the outside. Okay, and now this is all raised to the positive third power. Right? Well, I still want to get rid of my negative exponents there. So when, when it is unhappy, right, so it has a negative exponent, I say it's unhappy. To get it to be happy, right, it's going to flip upstairs. So this guy wants to go upstairs. Right, so when I write this down now, I'll have x to the fourth, right, when it comes upstairs it's now positive, x to the fifth, y to the fifth, z to the fifth, right, and then on the bottom 3y squared. This is still all raised to the third power. We still haven't used that yet. And at this point you could distribute, that 3 through to everybody and then combine those terms together, or you can get your x's together, get your y's together, and then distribute it through. And that's the way I'm going to do it. But either way works. Okay, so when I get my x's together there, when it's connected by multiply, I need to add those exponents. So that's going to be x to the 9th. Here, with my y's, right, you look at this. So these y's were connected by divide, so I need to subtract those exponents, right? And there's more y's on top than on bottom, so that means my y's are going to end up on top. So I have y to the third on top. I'll subtract those. And then z, right, there's nothing to combine with that z, so I'll leave it as z to the fifth, and then I still have a 3 on the bottom, all raised to that third power. All right, now let's give that power of 3 to everybody. So when I do that, a power raised to a power is multiplication, right? So x to the 9 times 3 power is 27. Y to the 3 times 3 power is 9. Z to the 5 times 3 power is 15. And then don't forget, you've got to give this one a power also. So we're doing 3 to the third power. 3 times 3 times 3 is 27. And so that will be my answer. And I know it's all simplified because there's no more negative exponents and all of my variables are together. Right? My x's are in one place, y's are one place, right? Whole numbers are simplified, like reduced if they needed to be. Okay, so that would be your answer there. So make sure you just know those properties of exponents and practice a few of those. All right, what about scientific notation? All right, well, with scientific notation, remember if it's written like this, right? So this is saying it's a really small number, right? And so to find what this would be in scientific notation, we need to figure out how many places do we need to move that decimal so that it's between the 6 and the 4. Because remember with scientific notation, our number has to be between 1 and 10. Right? So it has to be bigger than 1, smaller than 10. So that means it's going to have to be, so we want to write that as 6.49, because 6.49 is a number between 1 and 10. And then times 10, and since this was a really small number, right, because we have all these 0.00000, right, then we know it's going to be a negative exponent. And how many places did I have to move it? 1, 2, 3, 4, 5. So to the negative 5th power. So that's how we write that number in scientific notation. Okay. Now, let me give you something in scientific notation, and let's change that back, right? So if I have 8.82 times 10 to the let's do a positive power. Let's just do like a positive 4th power. Well, that means I need to move my decimal 4 places to the right. Right? If it was a negative 4, then I'd have to move it 4 places to the left. So here my answer would be, so 882, and then I need 2 zeros there. Right? So 88,200 would be that number written as a whole number, right? Changing it from scientific notation to a whole number. All right, let's see. Also, you should know how to do simplifying some radicals. So if you're given the square root of 108 x to the 15th y to the 11th. Okay, so remember with that 108, what you want to do is find the prime factorization of that number. So think about, what do you know that divides into 108? Well, it ends in an even number, so I know that 2 can divide into it, and 2 will go into that 54 times. Okay, and it still is ending in an even number, so I know that 2 can divide into that, right, which will go in 27 times. And then 27, right, can still break down more here, to 9 times 3, and then 9 breaks down to 3 times 3. All right, so I've got, these are the prime factorization, so I'm going to write those back inside here. So I have 2 times 2 times 3 times 3 times 3. And then you could write all of those out, like 15x's out, 11y's out, but I'm going to show you make sure you know how to do the shortcut on those, because that would take a long time to write those out. Now remember, since this is a square root, right, things have to come out in groups of 2. So I have a pair of 2's, so that gets to come out as a 2. I have a pair of 3's, so that gets to come out as a 3. Right? And then this 3 that doesn't have anybody to pair up with is stuck there, right? It's still stuck inside. So I can see that when it comes out, these are going to be multiplied together. So on the outside right now, I have 6, and then I'm going to leave some spaces there because I'm going to be bringing out some x's and y's. And then the 3 is still left inside. Right? So multiply those together when you bring them out. So now, to figure out this one, right, x to the 15th power, remember we're bringing things out in groups of 2. So we're really thinking to ourselves, how many times will 2 divide into 15? Well, it will go in 7 times with 1 left over, right? 7 times 2 is 14, but then there's 1x left in there. Right? What about with y to the 11th? 2 will divide into 11 5 times, so y to the 5th comes out, and then there's still 1y left inside. Okay, and so then that would be your answer. 6x to the 7th, y to the 5th, times the square root of 3xy. Okay, so just make sure you remember, like with square roots, they have to come out in groups of 2. Okay. All right, what about foiling? All right, so with this number 47, is a little FOIL problem, right? First, outside, inside, last. So if I'm multiplying these together, a times 2a is 2a squared. Then a times negative 7b is negative 7ab. Then 5b times 2a is positive 10ab. And then if I do 5b times negative 7b, it's going to give me negative 35b squared. And then I just need to look and see if there's like terms that I can combine together. And those middle ones are like terms. So I'll have 2a squared plus 3ab. Right? Negative 7 plus 10 is the 3. Keep the ab on there. And then minus 35b squared. So that would be your answer. All right, let's look at some factoring. So on this number 50, I want you to factor out the GCF. Okay, and so we're given negative 35x to the 4th minus 15x to the 3rd minus 5x squared. Right, so I'm looking at this. And I need to see, like, so I'm going to look at my number part first. So negative 35, negative 15, negative 5. Right? And I can see the biggest number that will divide into all of those is negative 5. Right? And if that leading coefficient is negative, you usually take the negative out with it. Okay? Okay, but what about my x's? Well, here I have 4, here I have 3, and here I have 2. So this guy only has 2 to give. So it can't give 3 or 4, right? So we're looking for the variables with the smallest exponent. So x to the 2nd. So negative 5x to the 2nd. Actually, let me write this over here. Is going to be my greatest common factor. But then I need to figure out what my leftovers are. So I'm not done yet, right? So I'm going to divide each of these by that negative 5x squared to figure out what's left over inside here. Right? So negative 35 divided by negative 5 is positive 7. X to the 4th divided by x squared. Well, when they're connected by division, we subtract those. So that's x squared. Negative 15 divided by negative 5 is a positive 3. X to the 3rd divided by x squared is just x. And then negative 5x squared divided by negative 5x squared. Right? All of these things are divided by themselves, so this is really a plus 1. Right? So don't forget about that plus 1 if there's something like this. That tends to be forgotten about. Because remember, you've got to think, the way you would check this is if you distributed this back through, you should come back with what you started with, right? So this is the answer. This is factoring out our greatest common factor, right? But to check it, we could distribute that back through. Because factoring and multiplying undo each other. Because really when we're factoring, we're really just kind of dividing there, right? All right, what if we have a trinomial? So let's try this one. So what if it asks you to factor x to the 3rd plus 3x squared minus 40x? So you always want to look and see if you can factor out the GCF, right? If there is one. Right, so here it looks like x is my greatest common factor, right? So then that will leave me with x squared plus 3x and then minus 40. Okay, but you're not done. It didn't say just factor out the GCF. It wants you to factor, and sometimes it'll even say like factor completely, right? And so we got to look at this trinomial and see if this trinomial will factor any further. So when we're looking at this, right, we're thinking what times what is x squared? Well, that's x times x. And then what multiplies to be negative 40, okay, so whatever that last term is, that adds to be positive 3. Right, so you're trying to think of all the different possibilities of what multiply to be negative 40. And usually I just start off with, what is 40? So 1 times 40, whoops, 2 times 20, 4 times 10, sorry, okay, and then 5 times 8. Right, and so if I'm looking at any of those, I'm asking myself, okay, is there any way if I added or subtracted these numbers together, I could end up with a 3? Yeah, if I'm looking at this last one, right, that is going to happen there. And so to get a positive 3, I need to have a positive 8 and a negative 5. So that means in my parentheses here, I'll have x minus 5 and x plus 8. Right, so this whole thing is your answer. And it doesn't matter whether you put x minus 5 first or x plus 8 first. It'll both be the same. Okay? Because multiplication, the order doesn't matter. All right, we're getting there, guys. We're getting there. Hang in there. You guys are doing so good. And this is a lot to remember for all of the semester. But glad you guys are here. All right, so what if you're asked to graph some exponential functions? So what if you're asked to graph f of x equals 3 to the x power? Right, so remember that this is really saying the same thing as y equals 3 to the x. So we could make a table of values just like we did before when we had linear equations, right, and pick some values here. Now, good values to pick for x would always be, you want to, whatever is going to make x 0 here is, or your exponent 0 is what you want to pick. So if we say 0 here, right, and then we do 3 to the 0 power, well, anything to the 0 power is 1. So that means I found one of my points is 0, 1. Right, but now let's do, might have to do a couple of them here. Maybe I'll do negative 1 and positive 1. So if I put negative 1 in there, 3 to the negative 1 power, well, that tells you to flip it, right, when you have negative exponents. So that's going to be 1/3. And 3 to the first power is just 3. So let's use these 3 points that we found, okay, and see if we can see what this is going to look like, or if we need to maybe do a few more points. When you're doing it on the computer, you're only going to have to, you only need 2 of the points. And you'd want to pick ones that don't have fractions in them, right? So I'd want to just put like 0, 1. So over 0, up 1 would be here. And then over 1, up 3 would be here. 1, 2, 3. Right? But when we're graphing it on paper, it's sometimes hard to, see exactly what it's going to look like unless we have more than one. Okay? So this is exponential growth, right? Because our base is bigger than 1. Okay, so when the base is bigger than 1, it's exponential growth. Right? If the base is less than 1, so if the base, well, actually not less than 1, but let's say if base is between 0 and 1, right, then that is decay. So if we had something like, y equals 1/3 to the x power, right, then this is exponential decay. Right, so exponential growth, as you're looking at it from left to right, it's going up, right? It starts off really slow, and then it just takes off. But on something like this, you could do the same thing and put your, put your points in there and stuff. But the way it's going to look is kind of like this. Oops. Okay, so if you have exponential decay, it starts off really high, and then over time it kind of almost levels out here. Okay? So just make sure you know the difference between exponential growth and exponential decay. All right, then on this one, right, we've got you deposit $400 into your account, or into an account earning 5% interest compounded annually. How much will you have in the account in 15 years? So this formula will be given to you on the test. Okay, so that's probably a pretty good indication that it's going to be on there, right? So A equals P times 1 plus R all raised to the T power. All right, so we're just putting our stuff in there. So A is our end amount, so that's what we're trying to find. P is the principal, so how much we put in first. So A equals 400 times 1 plus my interest rate. I've got to change that to a decimal, so 0.05. And then raised to the T power. T is the year, so raised to the 15th power. So then in your calculator, right, mostly this is just with a calculator, you're going to just do 1.05 raised to the 15th power, and then times that by 400. And make sure you notice where it says to round it. Is it telling you to round to the nearest cent? Is it telling you to round to the nearest dollar? Right? Look for those rounding instructions. Right? There will always be rounding instructions on ones like this. Okay, so when I put that in, I end up with $831.57. Right, because it says to the nearest cent, so I need 2 place values. Okay, and that would be my answer. All right, these next 2 questions, super easy as long as you know how to use your calculator, right? So it's saying use your calculator to find log of 55. So in some calculators, you'll hit the log button and then 55. But in other calculators, you have to hit the 55 first and then the log button. So you've got to know which way, right? And this one says round to 4 decimal places. So when I do this, this is going to be approximately 1.7404. It says 36, right? It says 1.74036, but that 6 is going to round that 3 up to a 4. Around the 4 place values there. Okay, and then the next one, now we're just doing the natural log, right? So using that natural log button, again, sometimes you'll have to do the natural log and then the 40, or the 40 and then the natural log. And so on this one, you should get 3.6889. Okay, will be your answer on that.
Hey, Becky?
Yeah.
I have a quick question. On some of the homework for this section, it said like round to at least X number of places. Does it matter if we round to more?
So when it says at least, that's fine if you put more on there. But if it says round to exactly, 4 decimal places, then make sure that's where it's at. And I'll just tell you on the test, it will for sure tell you to round exactly, right? It's not going to say at least. But yeah, on that homework, if you were to put more digits out, like if you put in 1.74036, it would give you the right answer. But on the test, where it's saying specifically you've got to be exactly 4 decimal places, then make sure you do that. That's a good question. Because sometimes, like if you're practicing that on the, on the homework, and you're like, wait a minute, what about on the test? What do I need to do? Yeah. Okay, we've got just a couple more here, guys, and then I've got another thing that's starting at noon with another class that I have. I thought that maybe we would have some time for some other questions, but I would just say reach out to me individually if you find that you have some questions that you want to go over. But like I said, the ones that I went through here with you today, if you know how to do these types of concepts and stuff, you're going to do great on the test. Okay. All right, so then here, right, we're going to use this like basis property. So we have 5 to the n power equals, now I'm taking that 125 and I'm trying to break it down into its prime factorization. Well, I know 5 divides into it, and it goes in 25 times, and then 25 breaks down, whoops, to 5 times 5. So 125 is the same thing as 5 to the third power. And then with my like bases, right, the bases are the same, then I can set the exponents equal to each other. So n equals 3 would be my answer. Okay, so use the prime factorization. If you get a number that you're like, oh my goodness, I have no idea, how to break that down or make that into these bases that will be the same, right? And then 79 on there is talking about solving some log equations. So if we're asked to solve log base 6 of 216 equals x, right? So on this type, whenever you have a log, like on the test, if you're just like, I am so confused what to do here, think about changing it to the exponent form. Remember, that is taking your base, so that little number, raising it to this power, and it's going to equal that. So 6 to the x power equals 216. Okay, and then it kind of comes back to this like bases property to see if we can use that here, right? And so then on here, if we do 216, well, 6 divides into that, and it goes in 36 times, and then 36 breaks down to be 6 times 6. So 6 to the x power equals 200, oh my goodness, sorry, I meant to put 6 to the third power. So again, right, put those exponents equal to each other, so x equals 3 would be my answer there. Okay, and then the last one let's look at, let's do one if we have like a negative number also. Make sure you know how to do this. So if I have log base 8 of z equals negative 4. So again, I'm going to change it to exponent form. So 8 to this power equals this. So 8 to the negative 4th power equals z. And most of your calculators, you can just put that in, right? 8 raised to the negative 4th power. And since it's a negative exponent, I know it's going to end up being a fraction. But you could write that as 1 over 8 to the 4th power. Right? And then 8 to the 4th power is 4,096. So I get 1 over 4,096 is what z is. Okay. So just make sure when you have that negative exponent that you remember you're flipping it, right? 1 over 8 to the 4th. Okay. All right. Like I said, I wish I had a little bit more time here, but I'm going right into another review for my 1010 class now. But if you come across some things on your, as you're reviewing and stuff, please, please, please reach out to me and let me know what I can help you with. I could make a little video for you to help you understand something more, or find a video that might help explain it to you. Or we could meet, you can meet me here in my virtual office. We can find a time and I can help you then. Okay, but good luck. I know you guys are going to do awesome. Thanks so much for coming and, learning some stuff here. And thanks so much for being such an awesome class.